My name is Dani Ljepava, and I'm a senior program manager at Microsoft with Azure SQL Managed Instance team. Been there since day one, since we've launched the platform, and I'm joined here with my colleague Mladen, who's going to introduce himself.
Hello, everyone. Great to be here with you at the Data Platform Summit. I joined Microsoft 6 years ago. I'm similar to Dani, working on managed instance for 4 or 5 years. Mostly working on the business continuity and disaster recovery areas, recently in the hybrid environments and data virtualization. Looking forward to your questions and to good discussion during the session.
Thanks, Mladen. Appreciate it. Here's our agenda for today. So once again, the first part will be presentation. In the meantime, if you have questions, please post them into the chat. My colleague Mladen will be answering to your chat questions. And then at the end, we are going to have a live Q&A session for any of your live questions. So today we're going to talk about the link feature for managed instance. We're going to learn about the feature, what it is, how it essentially can help you use Azure without migrating to Azure, or use it as a best possible minimum downtime migration solution to Azure. We're going to learn about technology used to power the managed instance link, and then we're going to learn about the upcoming scenarios of disaster recovery between SQL Server 2022 and managed instance using the link feature. So without further ado, let's first dig in what it is and why you should use it. So it's a hybrid connectivity scenario. It enables hybrid connectivity between SQL Server and managed instance in the cloud, which is our SQL Server implementation in Azure. Then it empowers you to use Azure at your own pace without actually migrating to Azure. So you can keep running your workloads on SQL Server, replicate your data to Azure, and then have all the benefits of Azure services. That will enable you to modernize your workloads, then again, with remaining to run on the SQL Server. And then when you're ready to migrate, the link feature will offer the best possible minimum downtime solution. How does it look graphically? It looks something like this. So we're replicating data near real time from SQL Server to managed instance. In one of the next slides, I'm going to talk more about the technology behind it, but suffice to say, at this point in time is that we're using availability groups and distributed availability groups, which is a well-known technology in SQL Server, to securely and with the best possible performance replicate data from SQL Server to managed instance. What you can do is, once the link is established, when you replicate data from SQL Server to managed instance, then you can use your replicated data on managed instance to offload read-only workloads, because replicated database on managed instance, the secondary, is available in read-only mode. I apologize, just give me a second. I had to clear my throat. So this is what it looks like in terms of the graphics. So application could be read-write, could be doing read-writes to your primary database on SQL Server, and then offloading read-only to the managed instance side. When ready to migrate, then the link could be severed, and then you are ready to move to the cloud. So this essentially describes a scenario of using Azure without migrating to Azure, then modernizing your workloads, making sure everything is fine. And then if you're ready and want to, you don't really need to, you can keep running the link for years and months at a time. If you want to migrate to Azure, then you can do that securely. Now, a bit more about technology. So we're using the link is essentially a distributed availability group. It is a concept well known for a couple of years in the SQL Server, or for the past several releases. It essentially is a bridge which bridges two AGs. So in this diagram here, we see an AG on the left-hand side, which is SQL Server, and on the right-hand side, an AG which is existing in managed instance. So distributed AG bridges is to those two AGs. Now, important to mention here is that this is just a technical diagram. We do not, so to use the link, it is important to say that you do not need to have an AG set up on premises. You do not need to have multiple servers. So with this technology, we support a single server without Windows Server failover cluster. The only exception is SQL Server 2016, which due to some technical requirements does need to have the Windows Server failover cluster in order to enable the always-on feature. But if you have an existing AG, you can use the feature, or if you do not, you can use a single node SQL Server as well. So it's pretty much open to everyone. Now, what versions are supported today? So we support 2016 and up, and to be very specific, Enterprise Developer and Standard Edition, you need to install certain cumulative updates and service packs in order to have this working, which is shown on the right-hand side. At this time, SQL Server 2016 is not supported. It's only because we still haven't got the time to get to it, but within the next period, we do plan to support 2017, and in some future cumulative update, the supportability for our feature will be provided. SQL Server 2022 officially will be supported at RTM. RTM means release to market. So when SQL Server 2022 is announced, then that's when officially the feature will be supported. The feature is available and supported in SSMS through automated wizards, or if you prefer to manually script everything, you can with PowerShells released in Azure SQL PowerShells starting from version 3.9.0. Now let's have a demo and let's see how this works. The demo will be based on SQL Server 2016 as the lowest common denominator. We wanted to show that it works on this older version of SQL Server that we support, and all the way, the experience will be similar all the way to SQL Server 2022. So what I have here is I have SSMS, and then I have my SQL Server 2016, and then I have one database here. And then on the other side, I have managed instance with no databases on it, which you see here from in the screenshot. Now I here confirm that I have SQL Server 2016 installed, and then it's a standard edition, which is a new thing that we have enabled through our SP3 and Azure Connect feature pack. Very specific, and this is only required for SQL Server 2016. It is not required for any other versions of SQL Server. You just need to install failover Windows Server failover cluster as a module. You do not need to configure any AGs. And this is only because in order to enable the availability groups in SQL Server configurator, in order to enable it, in order to be able to click this check mark, it needs to detect that Windows Server failover cluster module is installed. That's it. For 2017 and 1922, you don't need to have this. So I click on our automated wizard, manage instance linked, which is available in new SSMS. There are some pre-requirements which we check. Then I select a database or multiple databases at the same time that I want to replicate. Then I need to log into Azure. Then in Azure, I select my resource group, and then I select managed instance I want to replicate my database to. I have a couple in here. Then I click next. These are now advanced settings regarding AGs and DAGs. For most of the users, this is pre-populated, so you just click next. But if you're an advanced user, you might want to customize all of this. Then a script is generated. I run the scripts. The steps are being executed. I see automatically that a local AG and DAG has been created. So this is a single node system with one database. I use this query to show the seeding status. So the database has started seeding from SQL Server to managed instance. And then if I refresh the view on the managed instance side, I will see that that database is in replicating mode. So at first we start with auto seeding. That means transferring the entire contents of the database over to managed instance. And then when it's done, we enter the catch-up mode, which is the online real-time synchronization. So we see that the initial seeding has been completed, and now the database is ready to accept any updates that we have on the primary to the secondary. So this is done. I close the wizard. Now I check the updatability of database. It's a read-write on SQL Server, so that's our primary database in here. And what I'm going to do next is I'm going to create a table, and then I'm going to run it into loop. I'm going to be inserting some data into this table in the loop on the SQL Server. And then I go to managed instance. I see that the replicated, I see first that it is the managed instance. And then I see that the replicated database is read-only on the managed instance. And that's the same database that we're now getting from SQL Server. And remember, the loop is running on the SQL Server, inserting some data. And I'm refreshing this query on the managed instance side, and I see the number of records is being increased. And that essentially is telling me that the records being inserted at the SQL Server side are automatically near real time being transferred to managed instance, and the replication is working. Now I'm going to stop this replication here, because we no longer need it. And that concludes our this portion of the demo. So a couple of things I'd like to point out. First of all, we have built the link to be resilient. So in case that you are patching up your SQL Server, you're rebooting it, if there is a network connectivity loss for whatever reason, the link will stop working at a certain point in time. And as soon as the SQL Server is restored, or as soon as the network connectivity has been restored, then the replication will start automatically. There's nothing in addition that you need to do. So the link is resilient in that respect. The number of databases you can replicate to a single managed instance is limited by the number of databases that managed instance can host. And today, managed instance can host up to 100 databases. This is per one single MI. As I mentioned again, availability groups are not required, but we can use them if you have. And we support multiple node systems as well. And there's a limitation that we can have a single database per single availability group, which I'm going to talk more about in next couple of slides as the technical features. There are some networking requirements to get this working. There are some ports that need to be opened. So 5022 is a port that needs to be opened up between your SQL Server and managed instance. The SQL Server can, of course, be hosted on premises in your environment, and you would have a VPN link with the managed instance. Or you could host it also in a VM. So the 5022 is DB mirroring endpoint and needs to be bidirectionally available between managed instance and SQL Server, wherever it is hosted. Then in terms of the connectivity from on-premises, you would use the VPN or express route, or if you are using VM inside of Azure, then it's even easier. We just need to play with a couple of NSG rules or set up global VNet peering if your VM and MI are in different regions, and it's super simple to set up. All of this is documented online in Azure documentation. Now, a bit more technically how this works. So what we do on SQL Server, we encapsulate a database into a single AG, and then we build a distributed availability group link to a managed instance database, and this is done then for each database. So the link per se is database scoped, and that will open up some new scenarios, which I'm going to talk about in the next couple of slides. The primary databases on SQL Server are read-write, and replicated databases are read-only. Besides the replicated databases, you can also have additional databases on the MI side and on the SQL Server side, which are all read and write. This makes it possible for you to offload your read-only workloads to Azure, or to use it with Azure applications, or to copy the replicated read-only database on managed instance to a new database on managed instance, which will then become read-write, and then test your workloads and maybe production databases if you wish to before actually migrating to Azure. We've seen a lot of customers use this scenario to set up, to offload analytics, to do a read-only of analytical workloads in Azure while keeping running SQL Server on premises. Now, a bit more the technical story. How does it work? On the SQL Server side, we first create some security certificates, because authentication between SQL Server and managed instance is security certificate based. Then we create the DB mirroring endpoint. The SQL Server starts listening on the port 5022. Which is the same port as for AG, so it's exactly the same technology. And then managed instance and SQL Server exchange the security certificates in order to establish the trust. Once this trust is established in the security layer, then the two partners communicate and they join their AGs through distributed availability group. They exchange the encryption information. And then in terms of the actual data layer, the database seeding starts. That means copying the entire database content over, and then the near real-time replication starts. So whenever you have a new insert, a new commit on the SQL Server, it automatically gets transferred in real time to managed instance. Next, in terms of the minimum downtime migrations, once the link is established, because this is an AG technology, it's fastest out of the old technologies we have available. Let's say for migration, sometimes you can use log shipping, which has a delay of a couple of minutes to transfer the backup files and to restore them. Because this is AG, the replication is instantaneous, so is then the minimum downtime on the actual cutover. Some interesting scenarios, because the link is database scoped. That means one link per each database. You can use this technology to consolidate your workloads from several SQL servers to a single MI. So let's say if you're running multiple SQL servers, and these could be different versions of SQL servers, that's also important to say. So let's say this could be, let's say SQL Server 2016 and maybe 2019, and you want to modernize and consolidate everything to managed instance, then you set up the link per database from multiple SQL servers, and then you consolidate your workload in the cloud. Similarly, you could also use it to deconsolidate your workload in the cloud. Let's say in the case that you have a very large SQL server, which maybe has outgrown. Sometimes there are in some cases, hardware is just getting endlessly upgraded until it cannot longer host all of those databases, and maybe in those cases you wish to deconsolidate to several managed instances, then you can do that. You can then disperse your databases with near real-time replications to different managed instances, which then also could be located in different geographical regions if you maybe have that business case to support different regions. But looking at this diagram here, you can also have read-only workloads. So you could have a scenario where you need to replicate your SQL Server data to different Azure regions and then use your replicated data for offloading read-only workloads in different geographical regions, which of course would give you best performance in a certain geography. How does the migration cutover work? The initial replication is asynchronous, and it is asynchronous on purpose because of the performance reasons, because SQL Server managed instance could be very distant in terms of geographical distance, and then therefore network latency would be huge. So that's why the initial replication is asynchronous. When we're ready to migrate, we switch the replication to synchronous. And then we, of course, compare LSNs. We make sure that that your transactions have ended up on a managed instance before we do the cutover. And then when we're sure that the last transaction has been committed to a managed instance, then the cutover to the cloud is initiated. Now, what needs to happen is that you need to manually repoint the application string, the application connection string to the database from SQL Server to managed instance. That's a manual process required at this point in time. But then moving forward, we will be looking to improve that scenario as well. We're exploring the ways of how that even further could be automated. Now I'd like to show now a minimum downtime migration demo. It's a short demo. So coming back to our server, we see that our replicated database on managed instance is read-only. So this is the managed instance side. Then I'm starting my wizard. I'm going to say I'm going to fail over database to the cloud. I say, okay, this database I want to migrate. Then I sign into the Azure using my credentials. Then I need to confirm my subscription, and then I select between planned failover or forced failover. Planned failover is controlled, and forced failover is immediate without any controls put in place. And these are pretty standard terms for the SQL Server. Optionally, I can clean up my AG and DAG. The script is created, the script is getting executed. We're now comparing LSNs, making sure that transactions are over. That's all fine in the first attempt. And then we see that all steps have completed successfully. And that's how fast this migration was. It essentially was instantaneous. So what I'm going to do next on the managed instance side, I'm going to check the database updatability, and I'm going to see that my database now on the managed instance side is read-write. And that essentially means that now I can repoint my application and use the migrated database in the cloud for read-write workloads. And that's how simple it was to perform this migration. On this slide, briefly, I would like to compare, because we have an existing mechanism to migrate to managed instance called log replay service, which essentially is log shipping. By the way, LRS is also used with DMS. Maybe you've heard of data migration service, or maybe you've heard of SQL Server extension in Azure Data Studio. It's all powered by what we call LRS, which is log shipping. So essentially, log shipping is the primary vehicle of migration to MI today. And that's on the left-hand side. And on the right-hand side is the MI link as the new feature based on availability on AG Stack. And here I'm comparing and contrasting the two. I will not read this into details. You guys can do that, but essentially I will point out the main characteristics. So AG, of course, the link is much faster technology in terms of replication and the cutover. We support 2016 and up, but then if you have older SQL servers, 2008 up to 2016, then LRS would be a better choice, because with LRS, because SQL Server 2008 did not have AG and DAG support at that time. Now, one of the other major differences is that by using LRS to migrate, your database is not accessible during the migration. However, when you're using the link, the database is accessible read-only all the time. So you can test your migration, your setup, that everything, your data is in the cloud, that everything works fine before actually cutting over. For the link, you need to do some networking configurations, but sometimes that could be restrictive. And if you're using LRS, you can use public endpoint. So maybe that's another important factor for you to decide. Now, the link is also not impacted by any system updates or any failovers, which is an advantage. Then the link, you can run it for years and months at a time, versus log replace service being limited to 30 days only. So the link is superior in that respect. And then this is an upcoming technology that we'll be more investing into moving forward. This, I think I've covered the link in LRS, so I will skip this slide. And now a special topic for today, and I will invite my colleague Mladen now to do this part of the presentation. And this is a new scenario of being able to have a DR, disaster recovery, between SQL Server 2022 and managed instance in the cloud. Mladen, all yours. Go ahead.
Thank you, Dani. So far, we were talking about the unidirectional replication scenarios with the managed instance link. As Dani mentioned, those are either migrations or having a readable replica in the cloud that you can connect your Azure services to it, or read scale out to a multiple MI link replicas in the cloud. Now, of course, some logical extension of the functionality would be supporting the failover scenario or disaster recovery scenarios between your SQL Server instance and managed instance. So this part of the presentation is about that. So in order to claim that we have disaster recovery, support, it's not just about being able to fail over from your primary SQL Server instance to managed instance in the Azure, but you should also be able to fail back once you restore the functionality on your primary environment, be it on premises or in any other shared data center or other cloud provider. So there are two scenarios. One is usual, and then the other one is more of an advanced scenario, leveraging all the capabilities of availability groups and managed instance link. So let's start with what's coming really soon, with the scenario that will be available together with the RTM of SQL Server 2022 later this year. It's so-called offline failback. So basically, you have your usual managed instance link established between your SQL Server 2022 instance and your managed instance. At some moment, due to some disastrous event on your primary site, you will basically issue the failover command that Dani previously showed up, demoed, and your managed instance will become the primary. You can run, of course, you will need to repoint your applications to this instance. However, once you decide to go back, once you restored the functionality on your primary site, you should be able also to move all the data back. So this offline failback mechanism relies on the well-known backup restore mechanism using the backup to URL functionality and syntax. So you would basically take a backup of your database, put it on the Azure storage, and then restore the database, the latest copy of the database back to your primary environment. Of course, this requires certain downtime, so that's why we call it offline failback. What is definitely more, this scenario is good enough for less critical applications, definitely. But what if you have your tier one, really the most critical application for your company or your business? So that's where bidirectional managed instance link comes into the play with the online failback scenario. So that's showed on the right hand side. So basically everything that Dani presented so far with the managed instance link in one direction is coming also in the other direction. So in the future functionality that will enter preview later this year, the managed instance link will become bidirectional as long as you are using SQL 2022 as your primary site. So why is this functionality limited only to SQL 2022? The catch is that availability groups and always on technology is based on the replication of the physical chunks of your data, meaning that the underlying SQL engine structure needs to be the same on both sides. Hence, we can support this only with SQL 2022. Just to remind you, always on availability groups today or on any previous release of SQL Server couldn't replicate the data from the newer version to the older version. Here, we are making sure that there is a basically database engine parity between managed instance and SQL Server 2022, so that at any moment you can replicate your data using distributed availability groups or managed instance link in one direction and then in the other direction. Managed DR is just one of the scenarios where bidirectional MI link comes handy. There are other scenarios as well. For example, if you are already running your production in managed instance, and for any reason, for example, regulatory requirements or requirements of any of your end customers, you also need to establish, let's say, online replication of your data to some copy outside of the Azure. You will also be able to use this bidirectional MI link to copy the data from your primary workload or primary instance in Azure Managed Instance to SQL Server 2022 hosted anywhere. Just to make sure that we are completely clear, talking about bidirectional failover, at any moment the data is flowing only in one direction. So it's not active type of the replication. We are talking about replicating to SQL 2022 to managed instance or from managed instance to SQL 2022, depending on which side is primary. So hopefully this might be interesting for some of your scenarios. With this, I think we are done with the the official part of the presentation, and happy to answer any questions you might have. Feel free to post your questions in the chat or basically mute off and ask the question. Dani also reminded me about the start page where you can start if you want to learn more about managed instance link. This is the short URL that address that you can use to start learning about managed link and see all the demos and script examples that Dani already demoed. Thank you.
Thank you. Any questions? Comments or feedbacks or something that you would like us to do or to see in this product?
You can also use the opportunity and ask any questions related to Azure SQL Managed Instance in general, not just related to Managed Instance Link. If you'd like, we have enough time to answer all the questions. It's 15 more minutes, so feel free.
Andre said in comments, the product is exactly something we're looking forward to using. Thank you, Andre.
Thanks, Andre. Yeah, if you'd like, if it is not some kind of a business secret, would you like to share more with us? Which scenario would be interesting for you? Is it like unidirectional, bidirectional, and so on? Of course, if you can speak about that. Okay, so there is a follow-up question from Andre. Any thoughts on allowing larger database sizes on managed instance separate from the compute size? So just for setting up the context for everyone on the call, at this moment, managed instance supports up to 16 terabytes of the storage space, in both service tiers, meaning business critical and general purpose. With business critical service tier, the data is stored on the locally attached SSD disks, and with the general purpose service tier, the data is stored in the remote storage. So I guess yes. The short answer to Andre's question is yes. There is work in progress to support more than 16 terabytes. Now, the second part of the question was whether these larger database sizes will be separate from the compute size. So what Andre is referring to is that the larger sizes of the data up to 16 terabytes cannot be consumed with a smaller number of vCores, like 4, 8, 16, and so on vCores. Yes, the answer to that part of the question is also yes. What we're working on at this moment should offer much more flexibility in terms of the storage size and the compute size. Dani, would you like to take the question from Jack on the licensing part?
Sure, thanks for the presentation. Is there any feature planned in Azure SQL Managed Instance where we can synchronize data to a storage account? Oh, or the license one, I'm sorry. Do we need additional license if MIDB is read-only? So for the time being, if MIDB is read-only, that is, if you're using managed instance only as a disaster recovery, at this time, SQL Server license is required. And then on managed instance, there is of course, a licensing charge. We will be working on, and I cannot make any public promises on this, but VMs at this point in time, Azure SQL VMs have this benefit of a license-free DR, whereas if you're using your databases for passive DR in the cloud, you would not need to purchase a license. On the MI side, that's something that we are looking into. And I hope this answers your question.
Yeah, basically, just to add to this, you most probably know that there are some benefits and licensing benefits coming with the software assurance for SQL Server related to having a disaster recovery replica in Azure virtual machines. So yeah, we are considering aligning the experience and the licensing terms here also to be able to use this on managed instance.
Mm-hmm.
The question from Sheikh was, is there any feature planned in Azure SQL Managed Instance where we can synchronize data to a storage account. Not sure what synchronizing to storage account precisely means. What I can tell you is that we just recently GA announced the general availability of the data virtualization feature for managed instance. It is kind of a evolved poly-based functionality. At this moment, it is read-only. What is coming really soon is support for writing the data from managed instance to the storage account using the create external table as a select syntax. So it's coming later this year. This way, basically, you can save the result set of any T-SQL query that you're running on your managed instance in a set of the files, either one file or a set of the files partitioned by some of the interesting columns. For example, you can create the entire folder and file structure on the storage as a result of your query, partitioned by year, month, and so on. Not sure if that answers your question or not. I might think of a few other scenarios that might mean synchronization to storage account, but please feel free to clarify if this doesn't answer your question.
Okay, I think I can take Andre's question. Any additional work to provide better reporting on the Azure portal side? The portal reporting shows CPU utilization of almost 90%, but when I run the performance dashboard, and I will assume performance dashboard in SMS, it shows about 40% utilization. Which one is accurate? Looking forward to release of SQL 2022. So thank you very much for your comments on SQL Server 2022. Azure portal takes into consideration the entire CPU utilization. So besides queries, there are some satellite processes that are being executed. Now, I will indicate that difference between 40 and 90 is very high. I don't see that being logical, but then I can only say that that percentage should be very small in terms of like 5 to 10% maximum for satellite services, because it is also resource governed. So in that respect, I would say that portals should be more accurate, but in terms of this discrepancy, I do not know how to answer that, if it was at the same time or not, but I would advise opening up a support ticket for engineering to investigate if this is an issue for you. Sometimes it happens. What I also can say is that in the monitoring space, and because this is a monitoring question, we are working on a new version of SQL Insights. SQL Insights is something that you need to provision additionally. You can do that today from Azure Portal. And it is a tool that we will be investing more heavily into moving forward to provide a much better monitoring experience from the cloud, from the Azure portal itself, versus anything that we have available so far.
Time check, we are good. We have a comment from Ola. Ola said that this feature will help with their exit strategy, which is a regulatory requirement. So yeah, totally agree. For the financial industry, primarily, what we hear more and more is that regulators across the world are basically introducing more and more requirements regarding the just-in-case cloud exit strategies because of the cloud vendor concentration risk. It's not just people want to get out; it's just you need to prove to your organization and to the regulators that you will actually be able to go out if need arises. So we are closely watching this, and what I can share with everyone regarding this topic is that across the world we are really seeing regulators talking about this more and more. For example, in Australia, so-called APRA regulatory body, APRI, already came out with this requirement. In Canada, OSFI body also came out with the requirement. And then, it seems that in the European Union, there is a new act that is still in draft called Digital Operational Resilience Act, or DORA, which also in one of its part regulates this matter that anyone running any financial institution running critical software in the cloud, regardless of what cloud provider, what hyperscaler, should be able to prove that they have exit strategy in place and that they have regular, let's say, exit drills similar to DR drills. So I expect us to hear more and more about this in the future, and this bidirectional MI link definitely comes handy for all the people from the financial industry. And moreover, what we know from the history, some technical requirements and regulatory requirements that typically start from the financial industry or other highly regulated industries over time become de facto standard also in other industries that adopt that. So we definitely expect that there will be a lot of interest in the bidirectional MI link feature going forward for this specific reason. Thank you everyone for comments so far. Any other questions? Seems no at this moment. Still feel free to post your questions or to unmute and let us know anything that comes to my mind regarding managed instance, if we can answer any questions and so on.
Yeah, could be any general question, not only about the link feature, but anything that you want to share about managed instance, even good experiences if you want to share them, something you love, maybe about managed instance, or something that you would like us to improve, anything. How much more time do we have until the end of the session, Mladen?
8 more minutes. There is a question from Sheikh. A bit random, please shed some light on instance pools. Yes, instance pools is a concept that we introduced in Azure SQL Managed Instance a few years ago. It is supposed to be kind of a analog concept to the Elastic pools in Azure SQL database, where multiple managed instances share the same resource pool within the so-called instance pool, and few more advanced capabilities compared to a single managed instance. I guess the question is related to the roadmap of the instance pools, since instance pools at this moment are in the public preview. What I can share at this moment is that we are actively working on the next steps and bringing the instance pools to the next level of the functionality. No timelines that I can share with you at this moment. However, instance pools are something that we will continue investing in the future with much more capabilities within it compared to today.
Mladen, anything maybe new that we have released recently that you can think of?
I think since we have a few minutes, I think we can talk about a couple of features that we released recently, or even features that are coming soon. Of course, some of them are secret, but some of them are not so secret because everyone is waiting for those features for a long time, and we promised to deliver that. So starting with the features that we recently released, I already mentioned data virtualization. So you can transparently query the data stored in the Azure Data Lake storage or blob storage, stored in the Parquet or CSV or JSON format through the T-SQL. So basically, it's really straightforward experience. You should provide only the location and the credentials for this data lake account, and using any T-SQL commands, you can query it further. It's a good cost optimization technique. It helps with the simplifying the ETL pipelines. Sometimes you don't actually need to copy the data into managed instance to query it. You can query it from the data lake and just join the data with the local let's say dimension data and so on. Dani posted the link to the GA announcement. That's one of the features. What's coming very soon is GA of the business critical 16 terabytes. It's been in the business critical 16 terabytes in the premium series memory optimized SKU. So it's been in public preview for several months, and now we are GAing it very soon. We have a couple of improvements in general for the cost optimization. One of them that is coming soon, so you must be interested in this and stay tuned for that, is start-stop functionality for managed instance. That's something that we missed so far in our platform. So soon you will be able to basically stop, similar to VMs, Azure VMs, to stop your managed instance. Let's say if it is like test environment or some environment that you use only during the weekends or only during the work days, you can save some money by stopping it temporarily. That's another cool feature that is coming soon. What we mentioned during this presentation, and that I think is also very useful, is this capability to take a backup from managed instance and then restore it to SQL 2022. I mentioned that as a part of the offline failback scenario, but in general, this is very useful for customers that need to provide the copy of the database to their end customers. I know that some of the software vendors and service providers have this contractual obligation to, let's say, every day or every week, every month, provide a copy of the database to their end customers. Or if you are simply refreshing your dev test environment or refreshing some debugging or troubleshooting environment that you are hosting outside of managed instance, so far you should use you had to use Backpack. Now you can restore it to the SQL Server 2022 hosted anywhere.
Another point that crosses my mind is that we will also enable automated backups of replicated databases in Azure. So in the scenario where your SQL Server is primary, and then you replicate that database to managed instance, which is then read-only in your secondary, then we will be doing your backups of that read-only secondary in Azure. So that essentially means while using the link, you will get free, quote-unquote, backups in very secure and redundant Azure cloud of your SQL Server workloads. That's something that we have not mentioned. But
Thanks, Dani. There is another question from Andre. So basically, Andre discovered one of the capabilities available at the Azure SQL database, the other Azure SQL PaaS service, for querying multiple databases through a single external data source. Yeah, this is interesting concept of so-called fan-out query. You can have multiple databases with the same structure of the tables and columns, and basically you can issue a T-SQL command that will collect the results of the same query ran on multiple databases. It could be even hundreds of databases. I know that this concept is especially interesting to the service providers and software vendors that have, let's say, single database per tenant approach. So 100 tenants, 100 databases, and sometimes you need to run some management queries or whatever type of the queries on all of these databases. So the question is whether this will come to managed instance at any moment. So this is interesting, but frankly, it's not on top of our backlog at this moment. What I can also tell you is that this functionality in the capacity let's say, inherited from SQL database already works in managed instance, but it's not officially declared as supported. So I wouldn't recommend using it today on managed instance, because we are still to decide whether we are going to provide this functionality in the same, with the same experience as it is today in SQL database, or in somewhat changed experience, more appropriate for the instance level, for the instance concept that we have today on managed instance. So you can play with that, you can try it, it will work, but we don't recommend using it into production today on managed instance. By the way, this functionality is in the public preview in SQL database as well.